So I want to go over one more example of fraction simplification that's very common on the SAT, and it'll be something that looks like this. And the problem will either ask you to directly simplify it, or you'll just have to simplify it in order to find the answer to the problem. So how can you actually simplify a fraction like this? We see that it doesn't very easily lend itself to the methods that we were using before. There doesn't seem to be anything I can sort of factor out up here. This is two terms instead of one, which is in and of itself a little bit unusual. So I don't really know just by looking at this how to simplify this. However, you notice a sort of key difference between our previous examples and this one. In our previous examples, everything on the top and bottom was linear, right? You didn't have any power of x over 1. It was just like 3x plus something up here, and then maybe just x or like 4x or something down here. But now we have a polynomial, specifically a quadratic, right? We have an x squared. That means that this is potentially factorable, and that's precisely the key to these types of problems. So when you see something like this, where you can't really find a direct way to simplify it, and you have a quadratic or maybe even a cubic on top, the way to go is just to factor the top. Let me show you why. So again, at this stage, I'm not actually sure if this is simplifiable. What I'm about to do may or may not work, but it's definitely something you should try, because if it does work, then it's very helpful to move forward with whatever problem you're working on. So how can we factor the top? So we need to find two numbers that add to -3 and multiply to get -4. That's going to be +1 and -4. So that means that this top part factors into x plus 1 times x minus 4. Still all over x plus 1. Okay, so now we see something more familiar. Before we saw some problems where it directly gave us already a factored numerator or a factored denominator. And that's already sort of the SAT doing part of the work for us. Here, they are asking us to do the factoring. So in this case, now that we factored it, okay, we pretty clearly see now that there's an x plus 1 on the top and an x plus 1 on the bottom. The question is, can you actually cancel those out? From our previous lessons, we realize, yes, we can, because the top here is bound by multiplication. And when it's two factors being multiplied, you can divide it out. So x plus 1 divides out with the, if you group it like that, I think it's a little bit easier to see with the parentheses, cancels out. And so you're left with x minus 4. And that is your simplification of this fraction. So it's not really anything fundamentally new. It's just the only thing is that by asking us a question like this, the SAT is just adding one extra step that you need to do. And that extra step is to correctly factor the top. Or maybe there's a quadratic on the bottom and you have to factor that in order to actually get the cancellation that you're looking for in order to get this into the most simple form. So let me give you a few practice problems on fraction simplification. Some of them will be, of course, harder than others. But just, again, remember, if you have to simplify for any reason, if you have to simplify a fraction with a non-binomial top or bottom, or even not even a binomial, it could be a binomial, just if you have something like x squared or x cubed in the top and bottom, just try to factor it or factor stuff out. So why don't you give the practice problems a try now?